So with absolute value, we've talked about this before, and we actually had the problem related to absolute value recently. We want to kind of treat these like parentheses, except of course what we evaluate inside the absolute value, we will take the absolute value of at the end. Oops, not parentheses. Okay, so this is going to equal 7 minus 3 is just 4. 3 minus 7 is negative 4. All right, so absolute value just means how far are you from 0 in an absolute distance. So 4 is 4 away from 0, so it just becomes positive 4. It already was. The minus was outside of an absolute value, so we don't change anything there. And then negative 4 is 4 away from 0. So 4 minus 4 gives us 0. There it is. All right. All right, so what we're going to, this unit is really what you think of when you think of geometry class in the first place. We're going to be looking at area. We're going to be looking at volume, perimeter to some degree. We're going to be looking at all those things that when geometry comes to mind, everyone goes to. Now, we're going to start by learning about some area formulas that you should already be familiar with, at least most of them, if not all of them. And then once we're done with area, then we're going to jump into volume. So that's going to be kind of the process on our way through this unit. And as far as that goes, maybe before we get started, I want to remind everyone that this Friday is the deadline for turning in any work from units 4 through 6. After this Friday, I will not accept anything from units 4 through 6 for anyone. So make sure you are taking care of doing that. All right, unit 7, even though like some of the, you're going to get homework tonight, you're going to get homework this week. This stuff is technically, it's being assigned in April, but it's part of unit 7. Yeah, so you don't need to worry about turning that stuff in before April 30th. That's okay, so if that makes sense. So units 4 through 6, just focus on that. Okay, now area and perimeter of rectangles and parallelograms. This stuff isn't too bad. I kind of want to I want to breeze through some of this stuff because hopefully it's stuff that you easily remember. All right, now area, let me just do the really quick explanation that hopefully none of you need to see, but maybe someone out there it's going to benefit you. So the area, of course, is the space inside of the shape. How much space do we have inside of there? And the perimeter is the distance around the shape, if you followed all these lines. Now, an important thing to keep in mind as you're talking about perimeter versus area is that perimeter is a linear measurement, right? If you imagine walking around a field in a rectangular shape, you can measure the distance you walked, by measuring this line plus this line and so on. So the units for perimeter are going to be in this case, it's linear, and it's inches, so that's going to be inches. But when we're talking about area, we can't measure that in a straight line. We have to measure that in 2 dimensions. So if this box right here in the corner, if this represents our unit of area, that's an area that's 1 inch. Maybe I should erase this real quick. Okay, that's 1 inch by 1 inch. And so this creates what's called a square inch, right? So 1 inch squared. So where the units for area are squared units, it's inches, meters, centimeters, feet, whatever we're working with. But that's an important thing. Another thing that I want to point out at the beginning, because this is going to be where a lot of people make mistakes, is that your dimensions, when you're figuring out area, your dimensions always need to be perpendicular to each other. And I'll go into more detail. In fact, I'll probably repeat this over and over again to where you can't ignore this idea. So in a rectangle, we have right angles. So we don't have to worry about it with a rectangle because we already have all the sides are at right angles to each other. But other shapes, that's not the case. If you're dealing with a triangle, a lot of times it's not a right angle in the triangle. Sometimes there is. So in this case, when you have a rectangle, it's nice and easy because we already know the area formula for a rectangle. I'll do it this way. I'll draw a little rectangle. We write that as length times width, right? Do you have your iPad?
No, it's being weird, so I'm just doing it.
Gotcha. So we already have our two dimensions that are perpendicular to each other. So it's really straightforward. The length is 11, the width is 7, or whatever you want to call it. Doesn't matter which one's length and width. And so we can just multiply that together. Here's where I'm just going to kind of breeze through it, right? That's 77. And here's where our units are inches squared. Now, if we're going to walk around this thing, then of course, and this is only 7 inches, but if an ant, let's say, was going to walk around this, it would have to travel 7 inches on one side. So this 7 inches first, and then it would continue around and walk that 11 inches. And then it would go this 7 inches right here. And then it'd go around this 11 inches to back to where it started. So the total distance is just the addition of all the lengths of our sides. 7 plus 11 plus 7 plus 11 equals the perimeter. And of course, the perimeter here is going to equal, you add that up, and that's 36 inches because they traveled in a linear direction, in a linear way. So there are formulas for perimeter. I don't care about those formulas. You shouldn't waste your time learning them. I don't think that they're helpful that often, but it's just add up, figure out all the side lengths, add up all the side lengths, okay? If you like having perimeter formulas, you can find those on your own. I will provide a formula sheet for area formulas and the volume formulas. I don't have that online right now, but today we're just dealing with some basic formulas. Okay, so the basic idea of area and perimeter, I'm sure you guys are comfortable with that. But if you have questions about this, of course, we can work on this together. So I wanted to move forward to another problem because the rectangle is pretty straightforward, and you'll have some rectangle problems in your homework tonight. But with parallelograms, this is something that's almost as straightforward, but it can be a little bit more difficult. All right, and for this problem, we're only going to be looking at the area. And the area of a parallelogram, so I'll draw a little parallelogram right here. It's going to be basically the same thing that we already saw, base times height. I call it base and height this time instead of length and width. Honestly, well, base and height is really the best term for this, but if you want to refer to your rectangle as base times height, that's actually what I'm going to be doing moving forward. So we'll use base and height quite a bit and we'll want to get used to it. So the base would be that length right there. The height would be this one. And notice this is where the idea of the perpendicular dimensions really matters. Luckily, with this first one, they already give us the dimensions that we need, 8 and 15. Remember that your opposite sides of a parallelogram are congruent. So that's 15 inches as well. So calculation-wise, if I just rush through this real quick, that's going to be a 15-inch base times an 8-inch height. And when we multiply that out, that's 120 square inches. All right, but there's a little bit more to this that I want to talk about because the biggest mistake people will make is this right here. If they gave us that this was 10 inches, then a lot of people will use this length right here as their height for their parallelogram, but it's not the height. This is what we call a slant height. And we cannot use that because, again, this is where I have to keep driving this point home. That angle that's formed right here is not 90 degrees. If your two dimensions aren't 90 degrees off from each other, you can't use those as your dimensions. You have to figure out what's the dimension that's perpendicular. And maybe just to give a quick proof of this, imagine that you had a stack of papers and you're looking at it from the side. And this is a pretty big stack of papers. It's that tall. Now, if you were measuring the area of that side of the stack of papers, you would just do the length and the width, right? So length times width. Now imagine you took that stack of papers and you just tilted it all a little over. So you push these papers over until it created a parallelogram. Now, the fact of me pushing that over to the side just a little bit, did that change the area of the cross section in any way? No. Each piece of paper has the same cross section it did before. Sliding that stack over didn't change anything. But notice this is the dimension that I'm interested in, not this one. I don't care about that because if the area didn't change, then what I need to look at is the vertical height compared to the base. So just as a kind of a mental visual for why this is the case, hopefully that's helpful a little bit. So this problem, pretty straightforward, base times height. You will have some basic problems in your homework tonight. But like I said at the beginning, with this unit, we're going to be combining the stuff we've done in the last 2 units. There's going to be special right triangles. There's going to be trigonometry. We're going to be looking at Pythagorean theorem. We're going to be looking at, well, that's pretty much it. Maybe there's some other stuff in there that I can't think of right now. But those things will come into play because now look at this problem. There is a missing dimension here. Well, before we do that, let's not worry about the area just yet. Because hopefully you're looking at this and you're saying, okay, I cannot solve the area right away. But we can solve the perimeter. And remember, I'm not going to give you a formula for perimeter. I want you guys to look at this and knowing what you know about parallelograms, I'm just going to put P equals, and I want someone to write down what the perimeter of this shape is. So there are a couple answers up here on the screen. And as far as what we need to remember about parallelograms, remember that opposite sides are congruent. So if it's 18 on the left, it's going to be 18 on the right. If it's 22 on the top, it's going to be 22 on the bottom. Now what we run into is this weird thing where there's a 12. This is just a short bit of that total length. And for our purposes with perimeter, there we go, I don't need to worry about that 12. That will be important, but I don't need to worry about it for perimeter. So essentially for the perimeter, I'm just doing 22 plus 18 plus 22 plus 18. And when you add all that up, you will get 80. All right. So the perimeter for this particular problem is really not that bad. There could be problems where the perimeter gets a little tricky, but honestly, perimeter isn't one of our main focuses. So I'm not going to give you guys super challenging problems with perimeter. Okay, so let me clear just a little bit. All right. Now we want to focus on the area. All right, and let me bring back the area formula. I could have just erased it all, but whatever. The area of a parallelogram, that's a parallelogram, trust me, is base times height. All right, so the base, oops, right here is going to be the same. We already know that's 22. I'll just kind of, how do I want to show that? Well, I'll just leave it without it being on the bottom. We know it's 22, right? I hope we know it's 22. And then the height, this is what we need to solve for. And I'm going to leave it here for a few seconds to see if you guys can look at it and see if you can figure out how we're going to solve for the, excuse me, how we're going to solve for the height of this parallelogram. So a thought just came up that we could use inverse trigonometry right here, and absolutely we can. So if you wanted to take these sides right here, and we're essentially looking at a right triangle right there. So if you wanted to take this side and figure out with your opposite, adjacent, and hypotenuse, what maybe solve for this angle down here in the bottom left, you could do that. And then you have an angle, a side, and a side. This is a possible way of doing it. All right, I'm just kind of verbally talking through it. We're not setting up the problem because there's a faster way of doing it. But if you see it this way and you want to do inverse trigonometry to solve for, let me go ahead and write this in. If you do inverse trigonometry for that, and then you use trigonometry to solve for this missing side over here, that can work. But there is a faster way of doing it. And even with that answer, which is a correct way of looking at it, I want to make sure that's clear. But in that answer, we notice that this is a right triangle. So based on the fact that this is a right triangle, is there something else we could use to solve for the missing side length? So there it is. We're looking at the Pythagorean theorem right here. So remember, if we know two sides of a right triangle, we can solve for the third with that knowledge that a squared plus b squared equals c squared. C is the hypotenuse. The other two sides don't matter as much. If we wanted to, or what I like to do is label the shortest side A, the medium length side B, and then the hypotenuse is always C. But we could use Pythagorean theorem right here, and now it's just a straightforward thing. In fact, I am not going to set this up and solve it. I will say that we're solving for B. I'm just going to put B equals. I want you guys to solve for the height at this point. So as we're looking at this problem, hopefully you've all had time to set this up and give it a shot. Maybe you're in the last little bits before you are about to solve it. So you can do that on your own. You just double check that you got 13.4. This is a correct answer. So as far as this goes, it's going to be 12 squared plus B. Well, let me not call it B. Not that it matters what we call it. I'm going to call it H because it's technically the height that we're solving for. H squared equals, the hypotenuse is 18. So there we go. So we can kind of do this step by step rather than try and get it all done in one fell swoop in the calculator. So that's going to be 144 when we multiply 12 by 12. And H squared, we don't know, so we just leave it like that. 18 squared is 324. Now I can subtract the 144 from both sides. And H squared will equal 180. And now to get H, I have to take the square root of both sides. H will equal 13.4. And there it is. Now this is, I put a box around it, but that's not our final answer. This was a calculation we had to do in the middle of the problem so that we could solve the final answer. So that's going to be where this gets challenging. This is going to be where your trigonometry and special right triangles and Pythagorean theorem comes into play. All right, I'm not trying to trick you guys. I'm not going to do anything beyond what we've covered in class, but you will need to remember those concepts. So at this point, now I can plug in. That's the hard part because the formula itself is pretty straightforward. It's going to be 22 for the base. It's going to be 13.4 for the height. And now you can multiply that out. And some of you, I'm sure, have already done that. So feel free to write on the screen what you got as a final answer. There it is, 294.8 when you multiply those together. So as you're doing your homework tonight, the last step is simple. It's the first step or two that might be the more challenging part of this. And what else was I going to say to that? Well, actually, just are there any questions for how any part of this came about? Okay. Feeling pretty good. All right. If you do have questions, we can return to this. And actually, one thing that you can do is I highly encourage you guys always to do your homework at night, but you can bring your homework back to class tomorrow. If you look at it, you're going to see part of your homework is relatively straightforward and part of it is more challenging. Come back to class tomorrow and say, hey, can we look at problem number, this, and we'll go through it, okay? I don't want to go through any of the homework problems today because I want you guys to try it all on your own. But if you want to go through all of the homework problems tomorrow, we can do that. So let me clear this, and we're going to look at another example, and then I'll show you what your homework looks like. So with this one, I'm going to give you guys a number here. Without this, we couldn't do the full problem. So I needed to provide that. So let's start with the perimeter. And again, with this one, I'm just going to put perimeter equals, and you guys can figure that out on your own. All right. So I feel like that's been enough time if you're looking at perimeter. 110 is correct. So if this is 110, or sorry, if this is 40 on top, it's 40 on the bottom, it's 15 on the right. Just measure all or add up all those sides. 15 plus 40 plus 15 plus 40 is 110. All right, no fancy formulas needed for this. Just some quick addition. All right, now we get to the more challenging part, the area. In this case, it's base times height. All right. What do we know? The base is 40. What I don't know is the height. I can't solve this the same way. They didn't give me two side lengths of our triangle. We can't just use Pythagorean theorem. So let's just talk about it. What are some initial thoughts? How would you approach this? There we go. We have an angle. I want to remind you that none of this is stuff that we have not covered in class. It's just we're looking at it from a different perspective, so that might make it challenging. And there we go. So we do give us, or we are given an angle. So how can we use that? Yeah. Say that again. Yeah, find angles. Are you talking about in the triangle?
Yeah, so like 135 shoot over H. That angle is 135.
That's absolutely right.
And then you can flip that 90 degree over down there over because that's 90 degrees too.
That's perfect. So what are we left over? What do we have left over if we? So if we're focused on this angle right here inside of our triangle, what's that angle going to be? 45. We had the 135. And just to make sure that's clear for everyone, the opposite angles in a parallelogram are congruent. So that means if it's 135 in the bottom right, it's going to be 135 in the top left. But we also have this 90 degree, which is why right here we kind of shifted it up. If it's 90 degrees at the bottom of this perpendicular line, it's going to be 90 degrees at the top because these lines are parallel. And there we go. Now there's a reason for that. Yeah, go ahead.
Didn't you take 90 degrees down here and put it over where A and B is? And then add 90 plus 45 minus 180.
Now we can use triangle sum theorem. Yeah, we have 90 and 45. So what's this angle in the bottom left going to have to be?
No.
What is it? 45. Now, notice this is not drawn correctly. If this is really a 45, 45, 90, it would look very different. So it's not drawn to scale. It's not drawn accurately. You just have to be on to look out for that and aware that that will happen in certain diagrams. So maybe another way. Now this was all good way of seeing this. And this worked. This might be kind of a convoluted way for some people. Like, wow, that was a lot of work to get all these angles. Another thing to keep in mind, if I simplify this diagram a little bit, here are the left and right side of my parallelogram. There's the bottom of the parallelogram. If these two are parallel, which is by definition what a parallelogram has, these two angles have a name. We have a relationship for that. Do you remember what we call that? Actually, I won't make you guys try and remember. That's same side interior angles. They're on the same side of the transversal, both on the inside of the parallel lines. So these two are supplementary. If this is 135, then this has to be whatever is remained until we add up to 180. So that's 45 degrees. All right. So this is going back all the way to stuff we did in maybe January, February. But we've got it. We can do that. Okay. So lots of different ways of getting this. Let me clear all but the most important stuff from this diagram. So there we go. We now have this triangle that we're working with a 45-degree angle. We know that this is the slant height. Here's what a lot of people are going to want to do when they see a problem like this. They're going to want to take the base, which is 40, and multiply it by 15, but that would be incorrect. So we don't want to do that. We want to calculate exactly what the height of this triangle is, which is perpendicular. It has to be this perpendicular height right here. Okay, so with that all being said, what's our next step? What do we do?
You can find the length of the short leg by dividing the hypotenuse by that one.
There we go. Yeah. So if we know, and to draw this better to scale, it would look like this. All right. And that might help you guys kind of visualize this better. Oops. So there's your 45 degrees. Here's your 45 degrees. It's not drawn very clearly, so let's look at it like this. If that's 15, we can use what we know about special right triangles, absolutely. And just like was mentioned, we can divide by square root of 2 to get this length right here. And if we know that one, it doesn't matter. These are the same. So in both cases, I'm dividing by square root of 2. If you like that approach, go for it. That might be the easiest thing for you. Here's the good part about this. I don't care about decimals. All right. As long as you know you need to divide by square root of 2, do it on your calculator. All right. So that'll make your life a little easier. It was good that we went through and did it with rationalizing denominators before, but for this part, it doesn't matter. So what is 15 divided by square root of 2? 10.6. So both of these are 10.6, but we don't care about the bottom. So I'll just write it here. Now, maybe some of you looked at this differently and you weren't seeing a special right triangle. Instead, you were looking at this as a trigonometry problem. So if that was you, then maybe you would have come back, and I'll just do this real quick. Maybe you would have said 45 in the bottom left is going to be my reference angle. So this is going to be my hypotenuse. That's my opposite. This is my adjacent. So with those set up like that, I'm solving for the height. I know the hypotenuse. So at this point, that's going to be sine. And it would specifically be the sine of 45 equals the unknown height over 15. It's weird that we're using h for height and for hypotenuse here, but I think you can make sense of that. So if you did that, you would still get h equals 10.6. If I ran through that a little quickly and you got lost, I apologize, but that was what we did last test, just last Wednesday. So I'm hoping that you guys are not struggling there. Okay, so regardless of how you approach it, either with special right triangle rules, because it happens to be a 45, 45, 90, or with trigonometry, because that's still an option, we can now plug that number in, 10.6. Let me make our screen a little less cluttered. Actually, no, I won't. I'll just put a box to show this is separate work right here. So that's a quick calculation. 40 times 10.6 gives us our 424. We don't have units here. Let's pretend that we did. If it was centimeters, then that would be 110 centimeters for the perimeter. It'd be 424 centimeters squared for the area. Okay, are there questions on this? Are you getting super excited about having homework with this kind of stuff in it? All right. So let me go ahead and clear the screen. If some of this didn't make sense, you know, put a note beside it on your paper and we can come back and look at it. What I'm going to do real quick is I'm going to take you over to Canvas. You're going to be doing some PDF on Canvas. And you can see right here for the first homework, it says every odd problem on homework 1. So if we look at that real quick, you can see these are the ones where they give you all the dimensions that you need. Now there are going to be squares, rectangles, and parallelograms. Squares are not too bad. When it asks for the type, I don't really care about that part. But if you want to name it as a parallelogram, rectangle, or square, that's that's a good idea. Now it does give you your answers down here. There's an answer key, but take the time to actually calculate it before you look at the answers. All right. For homework 2, it says to do every problem. And when you look at this, I just want to make sure it's clear. It looks like you have a bunch of work here, but this is actually a repeat. The same stuff at the top is on the bottom. Everything can be done with decimals as answers, so don't worry about having an exact answer for anything. Like that means with the radicals still there. So right here you can see we're missing the height. You need to figure out a way to find that. When you have their height right here, this is a weird thing, but this 13 is still a slant height because if I zoom in on this, I'm just zooming in. I'm going through this just enough for you guys to have like a starting point. But if some of this you can't figure out, bring it back to class tomorrow. So that is not 90 degrees. So I can't use the 13 as the height of my parallelogram. I'm going to need to figure out what the perpendicular height is. Even though it's outside the parallelogram, that doesn't matter. We can still find it. All right. The next one is a rectangle, but we're missing one of the sides that we need. It only asks for area here, so don't worry about perimeter for these problems. And now this is not a special right triangle, 70 degrees, so you can figure out what you need to do to solve for your missing lengths. All right, so with that, it's 5 problems that require a little bit of extra work, extra prep work before you can do your formula. And with that, I've said about all I need to. If you are good to go, have a wonderful day. You can get started on your homework. If you have questions still, hang out and I will answer any of those questions. All right, have a good day. I'll see you tomorrow.